Now here I am going to show you an M file wherein I have designed a forward converter. Recall that in the last week resource I had included a forward converter design example. Now I am extending that to include inductor design with the core and also the transformer design with the core. So for that some extra files are needed. I have included course.m, ferrite.m, which gives you the data for the ferrite cores like the pot cores, EE cores and so on. I have included some for metallurgy cores, powdered iron cores. I have also included the wires table here. Just to show you, if I go into ferrite.m, you see here pot cores, EE cores, UU cores, RM cores, toroid cores. These are the various varieties that I have included, and I have put in the database AP, that is the area product, AC, the core cross section area, window area in the form of matrices, and I have also included the strings. And for all these cores, it is simple for you to add as much as you want into this database and then use it. In the wires table, I am going to show you that I have included the standard wire gauges details. These are the standard wire gauges starting going down from SWG 45 number to SWG 7 with all their bare conductor area and enamel thickness, all these things. So you have the wire gauge table and also the cores table, and in forward design.m I have included the actual design calculations. So what is there in forward design? Look at it. First, the specifications. We saw the specifications, VC48, VC minimum, VC maximum calculation. You can calculate it if you have tolerance, otherwise list the minimum and the maximum. Now the change that I have done, V0 is indicated as a vector 12 volts, and dV as another vector, the delta V, and I0 is also a vector 1 volt. These are single secondary, but if you have multi secondary, you just have to include comma and put in, let us say you can put in a 15 volts, you can put in a minus 15 volts, so on, and accordingly the ripple for the output correspondingly that vector will change and the I0 vector also will change. But now I will just bring it back into a single. So this can be used for multi-output forward converter. Then the designer variables, delta I have set it at 30% ripple, inductor current ripple. You can change it. It did that so that to reduce the core size. 20 kHz switching frequency, I have given two different flux densities, one for the flux density of transformer where I am setting it as 0.2 Tesla, another BML, the flux density for inductors as 0.25 Tesla. The efficiency of the transformer worst case minimum is 80%. Generally, when you design it, it will be much more than 80%. So this is a safe lower limit to calculate the input power. D max are set at 0.45. J is 3 amp per mm square, or 3 into 10 to the power of 6 amp per meter square. KW 0.4 for transformer, 0.6 for inductor, VD, and all these other calculations. You see, first the power calculation. P0 is 1.1 times V0 plus VD into I0 and summing it over all the windings, sigma. Turns ratio, find out the turns ratio. You have 1.1 times V0 plus VD of divided by D max VC min or D min VC max, which will give you N of all the secondaries with respect to the primary. N is a vector because I've used MATLAB's vectorization strength. Then the forward transformer design, now this is where the new thing comes in. Find the AP using the equations, and then go into the while loop. You call the course function which I have indicated here, and that will go into the course function and try to search for cores. So it will ask which core you want, whether you want to have a ferrite core, met glass, different core materials, and once you choose the material, it will go into that and then choose the specific core according to the area product calculated. Then it will give out the core, selected core, the selected course AC, selected course window area, and the area product. And using that, NP, ND, NS are calculated, and then you are calculating the wire gauges here, and for that I'm using the wires. You see the wires table, and the wires table will give you the AW wire cross section actual for the wires and the SWG standard wire. Then you do the window area check. If it is not fitting, it will go into the next loop. It will ask you which, again, to choose a core and so on. And then the inductor design comes in, finding out the value of L. For every secondary, you have an inductor, so L here will be a vector, and find out the energy of the inductor. And finally, you do a area product design just like we discussed, and do the core. I am using cores here again to select the cores, and then wires here to select the wire gauge for the inductor. And only here you also calculate the air gap, and goes into an iteration if it is not fitting. And then the output capacitor filter design, the output filter capacitor design, the diode designs, the various diodes, demagnetizing diode, the secondary blocking diode, and the secondary freewheeling diode, power switch, all those things. Then comes the display section where you display all the details. So let me just run this for you for this specification. So I will go into Octave. I am already in that folder. You see that, you see forward design and the other M files. So let me type in forward design, and then you execute that. It will ask you to choose a core material. I will choose ferrite, which is 1. I will choose ferrite, and then within ferrites it will ask you to choose pot codes, E codes. This is the data which I have entered, a minimal set of data. You can always increase it. You can add your own set of new cores and core shapes. Let me choose E core now, second, and then see that it may then it is asking for the inductors. I will again choose this one, again E core, and that's it. The design is done and it will get printed. You see the specifications and the design variables, forward transformer. You see the choice of E251307, the primary windings, the gauges, demagnetizing winding gauge, so on, the power rating of the switch, and the diode ratings, demagnetizing, blocking, freewheeling, inductor design. All these things are calculated, and you see the output. I will allow you to explore this and leave it to you to fine tune it and try to understand this forward design M file.